Welcome to Lesson 2 of our Matrix courses for use in data science. Today you'll learn how to do supervised learning models using ordinary least squares or OLS regression, using matrix operations to calculate the constants A and B of a bivariate or two-variable linear regression model in an Excel environment. Are you ready? Great, let's get going. Recall that from our previous lesson under OLS, we'll pass a line through a data set such that the square deviations of the actual points from the line is a minimum. In terms of the equations, we have the following, as shown in our presentation and statistics on linear regression. So we need to fit a line f of x equals a plus bx that estimates the y actual. So given that, we have the equation of f, which is just this summation of the squared deviations of the actual y points with the estimated y points f of x, which lies on the line. So writing f of x into a plus bx, we're going to get the summation of y actual minus a minus bx, and then you get the squared deviations and then sum it all up. Again, using calculus, we take first derivatives, equate to 0, then look for the critical points a and b. So we get this. So we equate that to 0, and then we try to solve for a and b. We're going to get the summation of y is equal to a times n plus b times the summation of x. And the summation of xy equals a times summation of x plus b summation of x squared. So don't worry, we'll just park this idea over here. And for now, we'll just call them the normal equations. We'll get back to this later. So writing the normal equations in matrix notation from our knowledge of the previous lesson, we can rewrite this into the multiplication of two matrices equals the matrix summation y and then summation xy. All right, changing themes a bit, we'll get back to that later. What if we had this system of equations in 7 equations and 2 unknowns a and b? We need to solve for a and b. And therefore, we try to rewrite this in matrix notation. So we will have the following. From there on, we can rewrite that as x equals the column of 1 and the column of x's, the b vector, which is just ab, and then the y vector, which is just the values of y. In this case, x will be 7 by 2, b will be 2 by 1, and y will be 7 by 1. So mind the order of the matrices so that you can keep track if you can do the actual matrix multiplication or not. So rewriting that, that's going to be x times b is equal to the y matrix. So the question there is, from our lesson in the previous matrix course, what we did was try to get the inverse so that we can move it to the other side. And therefore, we might be tempted to try b equals x inverse y. However, there's a problem with doing that because x is not a square matrix. So we cannot get an inverse if it's not at least a square matrix. And this is definitely not a square matrix. So therefore, it's not going to work. Therefore, we need to have a workaround for doing this. So we need to multiply something to x so that it becomes a square matrix. And it happens to be very convenient that if we multiply both sides by the transpose of x, so like so, what will happen is that the X transpose X will suddenly become a 2 by 2 matrix, which means it will be very convenient for us to multiply this to the 2 by 1 matrix and come out with some sort of equation or some sort of solutions. So let's take a look at the X transpose, and then this is what it looks like. And then if we multiply X transpose X, again, mind the order of multiplication. The X transpose has to be at the left side. Then X transpose X will look like this. Therefore, we'll have a 2 by 2 matrix like so. Kindly check the multiplications. You can double check. You can always pause the video and double check what's going on. Likewise, X transpose Y will look like this. And therefore, it's going to be the 2 by 1 matrix summation of Y and summation of XY. Now, what's very interesting about this one is that if we multiply both sides by X transpose, then we will actually get the normal equations. Although right now, that's just the number 7 rather than n. But this is because we had 7 rows. So if we had n rows, then without any loss of generality, then you're going to get this. So this is the normal equation in terms of n rows, n equations in two unknowns a and b. We will rewrite this as X transpose X equals B is equal to X transpose times Y. Now we know that X transpose X is a square matrix. We can now try getting the multiplicative inverse of this and multiply it to both sides. And therefore, we will get the solution vector X transpose X inverse X transpose Y. So, pay attention to the order of operations. It's a bit tedious, but if you're writing code for this one, it's simple to implement via code. So the solution is nothing but X transpose X, get the inverse of that, multiply to X transpose, then multiply to Y. So the solution is like so. So what are the steps to doing this? 1, you need to create the necessary matrices X, B, and Y. After that, number 2, you need to find the transpose of X. Then multiply it to X itself with X transpose as the matrix at the left. Then find the inverse of step 2 above, meaning the inverse of X transpose X. Find the inverse of that. That's step 3. Then the next step is you multiply the result of step 3 above and multiply it to the X transpose. Then finally, multiply the result of step 4 above and multiply it to 1. So we'll have a simple example just to show how to do this. And again, just a reminder, don't forget the column of 1s when writing down matrix X. So for example, you might be given a data set like this, and therefore we're just putting the solution vector over there so that we can remember the order of operations. So first we rewrite matrix X with a column of 1s, and then the x's themselves. Next, we find X transpose, then multiply X transpose to X. We will have this 2 by 2 matrix. Now we can get the inverse because now this is a square matrix. After getting X transpose X inverse, if you take a look at the solution vector, we need to apply that one to X transpose. So we're going to get X transpose X inverse times X transpose, which looks like this. And then finally, it's going to be multiplied to Y in order to get the solution 0.0009 and then 1.0014. And then this is what it looks like if you graph it like what we did in our statistics course. Okay, again, please review lesson 1 if you're a bit confused how these computations came about. And take note of the QuantProf Add-in in the website. If you have an old version of Excel and therefore the matrices are not popping up, then try to work the data provided in the video to do the linear model using OLS. Also take a look at the video description below for more details about the website, the QuantProf Add-in, our previous cash courses, especially on linear regression and matrices. If you like this video, please share, like, and subscribe to our channel. That's all that we have right now. See you next time.